Today we are going to solve the problem 2.8 of Griffith 4th edition Introduction to Quantum Mechanics. Before going into the problem, if you find this lecture helpful, kindly subscribe it and in order to get my updated lecture, also share it and join my channel for the growth of my channel. The problem 2.8 is use your result in problem 2.7 to find the field inside and outside a solid sphere of radius r that carries a uniform volume charge density rho. Express your answer in terms of the total charge of the sphere, that is q. Draw a graph of modulus E as a function of distance from the center. These are the question asked. We are going to solve one by one. First, find the electric field inside the sphere. For that, we are going to use Gauss theorem. Let us say inside the sphere, we are taking a sphere of radius small r, and the total radius of the sphere is capital R, inner sphere is small r. Then the charge enclosed by the sphere small r to the total charge is equal to uh, we have given with volume charge density rho. So rho multiplied by the volume gives you the enclosed charge by the sphere of radius small r, which is equal to 4 by 3 pi r cube rho. Similarly, the total charge by the entire sphere is q. So that q is equal to, the volume charge density. Then you multiply it by volume. That is 4 by 3 pi capital R cube rho. So here you can cancel this 4 by 3 pi, and here the 4 by 3 pi and rho. Then the ratio between the charge enclosed to the total charge is r cube, small r cube divided by capital R cube. Then we know the charge enclosed by the sphere of small r is equal to, you bring this q to the other side. So the charge enclosed is small r cube over capital R cube multiplied by q. Now you take the integral form of Gauss law, which is integral E dot dA is equal to the charge enclosed over epsilon naught. We know the first you take 1 over epsilon naught, and we know the charge enclosed is small r cube over capital R cube multiplied by q. Now you take the integral of left hand side, which is equal to E dot A. If you integrate dA, you will get total area, which is equal to 4 pi r square. Here you can see you can cancel this r square with this r cube, which will become small r. Then you bring this 4 pi to the other side. So charge inside the sphere is equal to 1 over 4 pi epsilon naught small r over capital R cube multiplied by the total charge q. Then we will see the electric field outside. Now we will see the electric field outside the sphere. Here also we are going to use Gauss law. So the electric field at any point R outside the sphere. Let us say there is a R outside. Let us say it is a small r, which is outside the sphere. So, according to integral form of Gauss law, integral surface integral E dot dA is equal to the charge enclosed over epsilon naught. Now, left hand side, if you integrate, you will get modulus E 4 pi r squared, because this area dA is equal to 4 pi r squared. Remember that this r is outside the sphere, which is equal to q enclosed over epsilon naught. Remember that the at the distance r, the entire charge inside the sphere is contain the Gaussian surface. So it involves the entire charge, because we are taking Gaussian surface with the radius, with a sphere of radius small r, which is outside this charged sphere. So then the Q enclosed is small q, total charge over epsilon naught. Now you bring 4 pi r squared, which is the area 4 pi r squared. If you bring this into other side, you will get 1 over 4 pi epsilon naught q over r squared. So here it is very interesting thing to note that the field outside the sphere is exactly the same as it would have been if all the charge had been concentrated at the center. So it is equivalent to all charges are concentrated at center. Like center of mass, this is the center of charge. Now we will move on to next. Now we have seen the electric field inside the sphere is equal to 1 over 4 pi epsilon naught R over capital R cube multiplied by Q, where Q is the total charge. Similarly, we have seen the electric field outside the sphere, which is equal to 1 over 4 pi epsilon naught Q pi Q over R squared. Here you can see inside the sphere everything is constant except this R, which is proportional to the electric field inside the sphere. So it is proportional to R. That means it will form a straight line. If you draw the graph between modulus E, y-axis is modulus E, and this is x-axis is distance. So you will get a linear relation up to the R. Here it represents, one represents the capital R, that is the radius of the sphere. If goes beyond the radius of sphere, then you can you know that the electric field outside the sphere is uh, inversely proportional to R square. Here you can see all other things are constant except small r. So when the electric field outside the sphere will fall over 1 over r squared. So this plot will be like this. Up to r is a straight line. Above the r, then this will be proportional to 1 over r squared. This will take. So, thank you very much for watching my video and supporting me continuously. Thank you very much.